Hey guys, welcome back to our YouTube channel Tech Begin. And today, day 4 of learning Java, our topic is inheritance and polymorphism in Java. Introductions to the first slide is introduction to OOP concept. OOPS means object oriented program and it is based on encapsulation, inheritance, polymorphism, and abstraction. Java is an object-oriented program is fundamental concept in Java that every developer must understand. It allows developers to structure code using classes and objects, making it more modular, reusable, and scalable. The core idea of OOPS is to bind data and the functions that operate on it, preventing unauthorized access from other parts of the code. Java strictly follows the dry, that is, don't repeat yourself principle, ensuring that common logic is written once and reused throughout the example in parent classes or utility methods. This makes the code easier to maintain, more organized, easier to debug and understand. What is OOPS and why do we use it? OOPS stands for Object Oriented Programming System. It is a programming approach that organizes code into objects and classes to make more structured. Now let us move towards the next slide. The next slide is what is inheritance. Java inheritance is a fundamental concept in object-oriented programming. It is a mechanism in Java by which one class is allowed to inherit the features of another class. The features means fields and methods. In Java, inheritance means creating new classes based on existing ones. A class that inherits from another class can reuse the methods and fields of that class. In addition, you can add new fields and methods to your current class as well. Inheritance promotes code reusability, method overriding, and polymorphism, which makes the Java program more modular and efficient. In Java, inheritance is implemented using the extends keywords. The class that inherits is called the subclass or child class, and the class being inherited from is called the superclass or parent class. Why we use inheritance in Java? The first reason is code reusability. The code written in superclass is common to all subclasses. Child classes can directly use the parent class code. The second one is method overriding. Method overriding is achievable only through inheritance. It is one of the ways by which Java achieves runtime polymorphism. The third one is abstraction. The concept of abstraction, where we do not have to provide all details, is achieved throughout inheritance. Abstraction only shows the functionality to the user and that organizes classes in a structured manner, improving readability and maintainability. Here we can see an example, that is first we gave class and then class name, and as you know we gave the method display, and then we told to print that parent class, and then we gave class child extends parent. That means here child is the subclass whereas parent is the superclass, and we use the keyword extends to acquire the features of parent class to child class, and we gave another function show, and then in child class we told to print child class. So the output will be parent class and child class. Now let us move towards the next slide. The next slide is types of inheritance. There are 5 types of inheritance related to Java. They are single inheritance, multi-level inheritance, hierarchical inheritance, multiple inheritance, and hybrid inheritance. And mainly we use single, multi-level, and hierarchical inheritance. And then we use multiple inheritance. And we should make a note that Java does not support multiple inheritance and hybrid inheritance directly through classes due to its language design. It facilitates aspects of these inheritance types using interfaces and other mechanisms. We will learn about it in detail in later part of the blog. The first one is single level inheritance, that is also called single inheritance. Single inheritance in Java is a fundamental concept where a subclass inherits from only one superclass. This means that the subclass can acquire the properties and methods of the superclass, enabling code reuse and extension of existing functionality. Here is a simple example. Here class A is superclass and class B is subclass. Class B acquires the features of class A, and so it is called as single inheritance. In real life example, we can take a family. For example, from one generation to next, imagine that we have cherished a family and we acquire the features of our parents and they acquire the features of their parents, and this is called as inheritance. And we acquire the features of our parents, and it is single inheritance or single level inheritance. The next one is multi-level inheritance. Multi-level inheritance in Java is a feature that allows a class to inherit properties and behaviors from another class, which in turn inherits from another class, forming a chain of inheritance. The mechanism enables a class to inherit methods and fields from multiple ancestors, but in a direct line where each class in a chain inherits from one class directly above. Let us see an example. Here is the example. Here class A, class B, class C are three classes. Class C acquires the features from class B and class B acquires the features from class C. As we already said that in the one class that one class is allowed to inherit properties and behaviors from another class, which in turn inherits from another class, and that is called multi-level inheritance. In real life analogy, we can say that class A, class B, class C are three members where class C acquires from class B and class B acquires from class A. In real life, let us imagine that class C is a person which acquires the features or the properties from their parents, which is class B, and then class B has their parents whose properties will be acquired from them, and let it be class A. And in this manner, we can say that multi-level inheritance requires minimum of three classes, that is class A, class B, class C. Then the third one is hierarchical inheritance. Hierarchical inheritance in Java occurs when one base class, that is superclass, is inherited by multiple classes. In this type of inheritance, all the features that are common in child classes are included in the base class. This way, the code becomes more manageable and reusable. Let us see an example. Here is the example. Class A is the base class or the superclass, and from class A, three different classes, that is three different subclasses will become, that is class B, class C, class D. and three of them, class B, class C, class D, will acquire the properties from a single superclass called class A. Let's understand it with a real life analogy. Imagine a school system to explain hierarchical inheritance in Java where one base class is inherited by multiple subclasses. The base class is school member. This class acts as a superclass for all types of people involved in a school. It could include properties like name, age, address, and all. Then the subclass, teacher, student, staff, these will be the subclass. These classes inherit from school member. Each subclass represents a different category of school member with its unique attributes and behavior. Teacher might introduce additional properties like subject specialization and methods like teach. Student could add properties such as grade level and methods like study. Staff might have properties like department and methods like work. And in this way we can take our real life examples also. Then the next one is multiple inheritance. Multiple inheritance refers to a feature in object oriented programming where a class can inherit properties and methods from more than one parent class. This concept allows a subclass to inherit behaviors and attributes from multiple base or superclasses, creating a rich, multifaceted hierarchy. However, it's important to note that Java does not support multiple inheritance for classes directly due to complexity and potential for ambiguity it introduces where a class inherits from two classes. Now let us see the graphical illustration of multiple inheritance. Here is the illustration of multiple inheritance diagram. Here class A, class B are two superclasses and class C is the one subclass. As we already know, the subclass will acquire the properties of more than one superclass, and that is called as multiple inheritance. Instead of multiple inheritance for classes, Java provides a mechanism to achieve polymorphism and code reuse through interfaces. An interface in Java is a reference type similar to a class that can contain only constants, method signatures, default methods, static methods, and nested types. Interfaces cannot contain instance fields or constructor methods. A class in Java can implement multiple interfaces, allowing it to inherit abstract methods from multiple sources. Now let us move towards the next slide. The next slide is about benefits of inheritance. As you can see, the first one is code reusability. This is the primary advantage. Child classes can inherit methods and attributes from a parent class, eliminating the need to rewrite common functionalities. This leads to less code duplication and more efficient development. The second one is reduces redundancy. By centralizing shared code in a superclass, inheritance minimizes redundant code across multiple related classes. This makes the code base smaller, easier to manage, and less prone to errors. And then the next one is method overriding. It provides method overriding also. And while comparing to the remaining all topics, it is easy to maintain. And the next one is facilitates abstraction. Inheritance, particularly with abstract classes and interfaces, allows for the creation of abstract designs that define common behaviors without specifying their implementation details. This promotes abstraction and helps in building robust and extensible software architectures. And the next one is support for Polymorphism. Inheritance is fundamental to achieving polymorphism in Java. Child classes can override methods inherited from the parent class, providing their own specific implementations while maintaining a common interface. This allows for flexible and dynamic behavior based on the object's actual type in runtime. Now let us move towards the next slide. The next slide is about what is polymorphism. Polymorphism in Java is one of the core concepts in object-oriented programming that allows objects to behave differently based on their specific class type. The word polymorphism means having many forms and it comes from the Greek word poly means many and morph means forms. This means one entity can take many forms. In Java, polymorphism allows the same method or object to behave differently based on the context, especially on the project's actual runtime. Key features of polymorphism: multiple behaviors, method overriding, method overloading, runtime decision. Multiple behaviors. The same method can behave differently depending on the object that calls this method. The next one is method overriding. A child class can redefine a method of its parent class. The next one is method overloading. We can define multiple methods with the same name but different parameters. The next one is runtime decision. At runtime, Java determines which method to call depending on the object's actual class. It allows actions to act differently based on the objects, and so it is called polymorphism. Now let us move towards the next slide, and it is about types of polymorphism. When something is polymorphic, it means it can take on many forms. In programming, polymorphism lets us treat objects as instances of their parent class instead of their specific class. There are two main types of polymorphism in Java. The first one is compile time and the next one is runtime. Compile time also called as static polymorphism and runtime also called as dynamic polymorphism, and which is nothing but compile time is method overloading and runtime is method overriding. Each type handles data and behaviors in its own way. In this section, we will look at both types and definitions. The first one is compile time polymorphism. Compile time polymorphism, also known as static polymorphism in Java, is a type of polymorphism resolved at the time of compilation. It allows methods to have the same name but perform different tasks based on parameters. Unlike dynamic polymorphism, which occurs at runtime, compile time polymorphism in Java is determined by the compiler, making it faster and more efficient since all methods calls are resolved during compilation. Java achieves compile time polymorphism mainly through method overloading and operator overloading to a limited extent. The characteristics of compile time polymorphism in Java are early binding, method overloading, efficiency, and method signature. Then the second one is runtime polymorphism. Runtime polymorphism, also known as dynamic polymorphism, is resolved during the program's execution rather than at compile time. This type of polymorphism in Java is achieved through method overriding, allowing subclasses to provide specific implementations for methods already defined in their superclass. The Java Virtual Machine, that is JVM, determines which method to call at runtime, providing flexibility and enhancing the scalability of Java programs. Unlike static polymorphism in Java, where the compiler knows which method to execute in dynamic polymorphism, this decision is made by the JVM during execution. This feature enables Java programs to handle method calls flexibly, adapting to different classes and promoting code reusability. How runtime polymorphism works means it is based on method overriding. Now let us move towards the next slide. The next slide is about method overloading. Method overloading is also called as function overloading. In method overloading, multiple methods can have the same name in a class but must differ in parameter count, parameter type, or parameter order. The Java compiler decides which method to call based on the method signature at compile time. Let us see an example. Here is the simple example that we gave class and class name as mathoops, and in that we gave int add int a comma b, and we told that we should return a plus b, and then we gave double add double a comma double b, and in that we gave return a plus b. Here we gave two times the same method add. While using the int we gave add, and while using the double we gave add. The method is same, but in that the parameters are different. In the first case we gave int a and int b are two parameters, and in the second case we gave double a and double b as two parameters. Well, both are completely different, so we can take this as method overloading example. And there are also different ways of method overloading in Java, and they are changing the number of parameters, changing data types of arguments, changing the order of the parameters of methods. In this slide we use that changing data types of the arguments. The arguments are a and b, and we changed their data types. In the first case it is int, and in the second case it is double. And there are also another two, that is changing number of parameters and changing the orders of the parameters of methods. And this is about method overloading, which is done at compile runtime. And let us move towards the next slide. The next slide is about method overriding. Method overriding is done at runtime polymorphism. Method overriding in Java is a feature that allows a subclass to provide a specific implementation for a method that is already defined in its superclass. This concept is a core aspect of polymorphism, specifically runtime polymorphism, enabling dynamic method dispatch. The key characteristics of method overriding are inheritance, same signature, specific implementation, and runtime polymorphism. The rules for method overriding are access modifiers, final methods, static methods, private methods, and constructors. Here simply we can see an example, that is class, and the class name is animal, and we use the method sound, and in that we told to print animal sound. And again we gave class dog extends animal, where dog is the subclass and animal is the superclass. And again we gave the same method, that is sound, and in that we gave to print bark, where we gave the method same again, and that is overriding. And in the main class we will give animal, my animal equals to new animal, and animal dog equals to new dog. and then we give new animal and new dog as two another methods, and then we will use animal dot sound and dog dot sound. So in these two cases we use animal dot sound and dog dot sound, where sound is to two same methods but we use two different classes, animal and dog. So the output will be animal sounds and barks. And this is method overriding, which is done at runtime polymorphism. Now let us move towards the next slide, and the next slide is advantages of polymorphism. The first one is flexibility. Polymorphism allows for more flexible and dynamic code where the behavior of an object can change at runtime depending on the context in which it is being used. The next one is code reusability. Polymorphism provides the reuse of code as methods with the same name can be used in different classes. And the next one is reduced complexity. It can reduce the complexity of code by allowing the use of same method name for related functionality, making the code easier to read and maintain. And the next one is code extensibility. Polymorphism enables code extensibility as new subclass can be recreated to extend the functionality of the superclass without modifying the existing code. The last one is better organization. Polymorphism allows for better organization of code by grouping related functionality in one class. And this is the advantages of polymorphism. Now let us move towards the next slide. The next slide is about inheritance and polymorphism together. Inheritance and polymorphism are fundamental concepts in Java object-oriented program that often work together to create flexible and reusable code. Inheritance establishes an is a relationship between classes where a new class derives properties and behaviors from existing class. Polymorphism means many forms. It allows objects of different classes to be treated as objects of common type. And how they work together means method overriding. A subclass can provide its own specific implementation for a method that is already defined in superclass. This is direct application of polymorphism built upon inheritance. When a superclass reference variable points to a subclass object, calling the overridden method will execute the subclass version demonstrating polymorphic behavior. In essence, inheritance provides the structural foundation by defining class hierarchies, while polymorphism leverages this structure to enable dynamic behavior and code flexibility, allowing you to interact with objects of different types through a common interface. And the next slide is about real world example. While coming to the inheritance, we already discussed the real time examples, and here we gave another example, that is car, and from car we get electric car, where electric car acquires the properties of car. And while coming to polymorphism, start engine behaves differently for petrol car and electric car. While coming to petrol car, we started by using petrol, and electric car it requires some electricity to start the car. So the start engine is totally different from petrol car and electric car. And summary and the next slide is summary. Inheritance and polymorphism are key OOPS concepts, key OOPS features. It helps build maintainable, scalable and reusable code. And the last slide is quiz or practice questions. Here are the 3 questions that you should practice for today. The first one is, what are the types of inheritance supported in Java. And the second one is define method overriding with an example. And the third one is how is polymorphism achieved in Java. This is the last slide, and we have completed inheritance and polymorphism, and in that method overriding and method overloading, and also polymorphism types and inheritance types. And today day 4 of learning Java is completed. Thank you.